Okay, good afternoon, everybody. Today's lecture is on the remote sensing and GIS for the coastal zone management. Before going directly into the topic, let us see what is actually actual definition of the coastal zone, because this is very important to understand what is a coastal zone. Coastal zone is a transitional area between land and the sea. In the picture, if you see that yellow line, it is a part of the land and the part of the sea. So it is the transitional area between land and the sea. So coastal zone is, you can say, on the coastal zone there is the effect of the land terrestrial process. Also there is the effect of the ocean. So it is a band rather than a line. When we talk about the land and water boundary, then we talk about the line. So the land and water boundary, if you digitize, it will come as a arc or line or polyline. But when we talk about the coastal zone, it's basically a area. So if you digitize the coastal zone on a GIS, it will come as a polygon. And the width of the coastal zone is varying from place to place, which is determined by the interaction of the marine and the terrestrial process. And the width of the coastal zone is not same everywhere around the globe. Also in your country, if you have a coastal zone, you can see the coastal zone. It varies from the place to place. Like in India, we have a different coastal zone width in the east coast than the different coastal zone width in the west coast, because it is determined by the interaction between the marine and the terrestrial processes. If the marine processes are very strong, the coastal zone will go far deep inside the land. And if the terrestrial processes are very strong, they will push back the coastal zone towards the ocean, then coastal zone will be narrow. The zone occupies less than 18% of the surface of the globe. So the area is not very high. It is only the 18% of the total land surface of the earth. And if you see the entire worldwide, the total coastal length, which is around 1 million kilometers, out of this 40% is only accessible. That means where we can go, and that is temperate enough to be habitable, where a human being can stay. Only 40% of the total 1 million kilometer long coastline. But yet it accommodates more than 60% of the world population, because civilization started around the coast throughout the globe. That is why from the prehistoric time, people started living in the coast, then slowly people start migrating towards the land. So, and also the coastal zone, there are a lot of chances that people will survive because a lot of resources are available in the coast. So population is already very high in the coastal zone, and it is gone increasing with civilization. So 60% of the population are residing in the coastal zone, where the area is only 18% of the land surface. That means population density is very high in the coastal zone compared to the other part. So if you see some important bullets for what we should study the coast, it is around 18% of the surface of the globe. That is what we have already told. 60% of the world population are living within this coastal zone. 2/3 of the major cities of the world, they are in the coastal zone. In India, except Delhi, all the other 3 metros, particularly Chennai, Mumbai, Kolkata, and also a few big cities like Vizag, they are all lying in the coastal zone only. Population density, as total number of population is high, the area is less, so density of population will be very high, which is 6 times higher than the non-coastal areas. This is very important bullet. 90% of the world fish catch comes from the coastal water, because coastal water is very productive. So that means fishes gets their food from the coastal water, and it is productive because mainly because the lots of nutrients are being carried from the land by the rivers which are meeting in the coast. So that is the main reason the coastal water is very productive water. So that's why 90% world fish catch comes from the coastal water, which is very important. There are lots of island countries, small countries, where majority of the GDP comes from the mainly tourism and the fishing. As I told you, it is a part of the land and part of the water. So 8% of the ocean surface comes under the coastal zone. 8% of the ocean surface and 18% of the land surface. 75 to 80% of the global sink of suspended river load, they are happening in the coastal zone. That means the river is bringing a lot of sediments before they come and meet with the ocean from the land part, and that sediments they are dumping in the coastal zone, and it may form a delta depending on the other geological situation and other oceanographic condition. or it may form as estuary where the sediments will be taken away by the littoral drift and the other currents. So, but 75 to 80% of the global sink of the suspended river load are happening in the coastal water. 90% of the global sedimentary mineralization, because the geologists will understand there are three ways of forming minerals. Maybe it is the igneous process or sedimentary process or the metamorphic process. So 90% of the global sedimentary mineralization are happening in the coastal water. So coastal zone is very important from the humanity point of view. At the same time, it is very fragile because the coastal ecosystem, if you disturb one part of the coastal ecosystem, it is going to be disturbed like the chain reaction, the other part of the coastal ecosystem. So it's a highly fragile ecosystem of the global. If you see the global ecosystem, it is very fragile. It's a very active zone, particularly you can see it is highly dynamic. So it's a very rapid transition, gradients and the variation. There is a rapid variation of the coast, particularly if you see when you come from the land towards the ocean, lots of parameters they vary. And in the ocean also, which is the part of the coastal zone, even ocean also lots of parameters vary. If you go in, inside the depth, lots of things varies in the water also. Because it is highly dynamic, it's very difficult to put the boundaries. There is high water time when the water goes towards the land. In the low water, the same water recedes back towards the ocean. So it is difficult to put the boundaries and define the coastal zone very accurately. Also, it is subject to multiple uses. In the next slide, we will see lots of uses are there. Lots of people use coastal zone for the various purposes. No parts in the globe they are being used as like the coastal zone. So coastal resources are highly exploited over time. You can see the is a schematic diagram of a coastal zone. Lots of activity, industry are coming up, quarrying activity, sand mining, oil extraction, agricultural activity, urban areas are coming up in the coast. Lots of tourism activity where fishes are being exploited, fish farming, military activity, dredging activity, irrigation, erosion control structures, dredging is being taken place. Lots of new land is being reclaimed, waste dumping, bulk transport. So many activities are happening in the coastal zone, and all these activities, whatever is being shown over here, they have certain kinds of negative impact on the fragile coastal ecosystem. So the basic concept of the coastal zone management is mainly into how to use the sustainable way of the coastal resources, how you can manage these activities. It is not that you will not do any activities in a coastal zone for the national importance, for the human subsistence, for the human livelihood. You have to use the coastal resources. You have to go for the new harbor or port. Lots of different activities, particularly in the border with the other part, like in Bangladesh coast, Goa coast, Pakistan. You need to do lots of testing. From the Odisha, Wheeler Island, or the Dr. Abdul Kalam Island, now it is named. So lots of missiles are being tested. Even our ISRO, all the rockets which are gone there from the SAR center in Sriharikota, it's also a small island. So these are all happening in the coastal area, which is very important for the national importance. We cannot say no, but the purpose of this particularly coastal development is how to make sustainable use. So we have to see the overall impact and how to minimize the impact so that our next generation they can use the same resources. That is the basic purpose of sustainable use. So if you summarize all the activities, it has been seen that lots of intense agriculture activities are happening in the coast, like in the form of lots of fruits and vegetables. Aquaculture activities are happening. It's a one kind of artificial fishing, fisheries activity. Lots of, as I told, 90% of the wild fish catch comes in the coastal zone. So lots of fishing activities are happening in the coast. Exploitation of the minerals, offshore oil exploration, onshore oil exploration, sand mining, salt extraction, they are happening in the coast. Lots of industries are coming up in the coast, like shipbuilding industry, ship maintenance industry, ship breaking industries, like along in the Gujarat. Lots of oil refineries by Oil India, ONGC, they are at the coastal zone. Fish and the marine resource processing industries are there in the coast. Of late, the coastal zone is a highly attractive place for the tourist and recreation purpose. Wherever there are good beaches, so they are the places where the tourists always want to go. Swimming activities, sailing, ecotourism. So they are the all concepts which are coming up of late, particularly from the tourism point of view. Lots of infrastructure are happening. Lots of ports and harbors are coming up. pipelines for transportation of the gases and other things, canals, road in the coastal area, transport, navigational activities, navigation, communication, particularly where the places where erosion is happening, erosion is rampant. We try to reinforce the coast using breakwater, seawall, dikes. So those kind of infrastructure are coming up in the coast. Above all, lots of, as I was telling, particularly in the border area, international border, where lots of activities from the defense point of view, from the naval point of view, from the coast guard point of view, those activities are happening in the coastal area. So this is the n number of activities are happening in the coast. Now we have to see what are the various kinds of impact of these activities and how you can sustainably manage them. So this is what is the basically coastal zone. The major highlights that is a highly population density, high degree of urbanization. Lots of new cities are coming up near the coast. Lots of 5-star hotels are coming up to attract the tourists very near to the coast. It's a very fragile and a complex ecosystem and the habitats. This already we are discussing. Lots of high density economic activities, infrastructure in the coastal area happening. And that is why there are a lot of conflicts. Whenever there are n number of activities, conflicts will be more. Competition will be the more for the resources. Resources in the sense land resources, marine resources, water resources. Lots of people want to use that resources for their own benefit. So there is a conflict in it. So finally, it will give you over exploitation of the natural resources. So because of the over exploitation, then ecology is going to be destroyed with times to come. So there is a over exploitation of the natural resources in the coast. Pollution of the environment in the coastal area, the people dump a lot of industrial waste, agricultural waste, thermal waste, thermal industries, nuclear waste. They're dumping in the coastal environment. A lot of pollution are happening in the coastal area. So that they in turn causing the degradation of the coastal environment, loss of the biodiversity, natural habitat. Lots of biodiversity is being degraded in the coast of late. It has been seen like destruction of the coral reefs, the destruction of the mangroves, seaweeds, seagrasses, lots of things they are happening. And also the coastal wetland, which is also very important for the breeding site of the various kinds of fishes. There are the tortoises, there are crustaceans. They all are getting suffered because of this degradation of the environment. Then of late it has been seen the various places of the coastal zone is highly erosion prone. So we need to protect those part of the land because they will be eaten up by the sea with due course of time. Also natural hazard, that is also another important area which we need to highlight, particularly when the safety of the human being is concerned. At the population density is very high, lots of people are living in the coastal zone, particularly the low elevation coastal zone where the elevation is less than 10 meter height. So those areas are highly vulnerable for the tsunamis, for the storm surge, for the cyclone. So these are the activities which are happening, particularly in the east coast of India. They are highly prone to cyclone, storm surge, tsunamis, those kinds of natural hazards. Along with this, there are so many other hazards are happening: coastal pollution, coastal erosion, saltwater intrusion into coastal aquifer. They are the other chronic sea level rise disaster they are happening in the coast. That is another issue, one of the major issue which you also need to take care of coastal environment is concerned. Because of all these things, there are also it has been seen there are a lot of social inequality has been increased in the coastal zone and poverty has been increased. And because of this 5-star hotel, the industry, the local people are not getting much benefit. They are bringing people from the outside. They are getting employed, but the local people they are not getting job and other things. Because of those hotels and the industry, local people are not recruited that much. So finally, there are a lot of inequality happening because nowadays the fishermen's son they don't want to do fishing. Basically, they want to do some service or something, so that they are leaving the coastal zone and going. Migration is happening towards the towns and cities. They want to get a white collar job and other things. So the traditional livelihood they are living. So that is another issue. Inequality is increasing. Whenever you will talk about the coastal zone management, you have to take care of these aspects also, because that's why we told that there is a role of the sociologist or anthropologist. They have to be part of the team when you are planning any coastal management plan. It is not only the scientists can do. So that's why the coastal management involves the planning and the organization of the development processes and the control the activities of the coastal zone aiming at the sustainable use of the natural resources of the coastal zone. That's what I'm telling. There will be activities. There will be lots of activity happening. You cannot say no, but you have to plan the activities, you have to control the activities. It should not be the activities which will be rampant. without any planning. So without anything, what is going to be the environment impact assessment, what will be the exploitation of the resources, how the project is going to be sustained for another 20 years. So all those things has to be there when you are going for any mega project in the coastal zone. So that is what we call the coastal zone management. So nowadays we talk about the integrated coastal zone management, because we will see of late it has been seen that lots of departments or subjects or experts are involved in the coastal zone management. Nobody can say that I am a coastal zone manager, because coastal zone management activities involves lots of disciplines. So you need to have a geologist, geomorphologist, social scientist, forestry, agriculture expert. So these are the all geographer, geomorphologist. So it's a job of all the people to come together, work together, and come out with a proper plan. So for this coastal environment, you need lot of information. Lots of information you need to carry for the coastal zone. So those information basically should be an open system. So coastal zone management should be an open system. Coastal zone management information system we talk about. If you want to develop an information system, like lots of data can be retrieved, it has to be an open system, because the data will be various kinds of data. There will be raster data, there will be vector data, point data. Lots of data will be coming from the coastal zone. So you need such kind of information system where you can integrate all those data, and they can be retrieved whatever data you need to develop any particular coastal zone. So those kinds of information system is very much needed when a country like India is concerned. But unfortunately, so far there is not such kind of information system is happening in a national level. Maybe in a small sector, in a small part of the coast of a state, which is highly proactive states, they're taking a lot of interest in the coastal zone. This type of information system is available, but not at a national level. So this is what I was telling you. So there was no coastal zone manager as such. Most of the time, the coastal zone management is the responsibility of the different government organizations. Coastal zone management involves several disciplines like hydrology, soil expertise, environmental expertise, forestry, agroeconomy, physical planners, sociology, anthropologists, economists. So those all, this is a partial list. There are a lot of other disciplines like geographers, geologists. These also should be a part of the team. Then you can come out with a proper plan. When Indian coast is concerned, you can see basically we have a long coastline of around 7,500 long kilometer coastline. This is a satellite data of IIRS-1C WIPS data. We have a total 7,500 kilometer long coastline. We have East Coast, we have a West Coast, we have Andaman Nicobar Island, we have a Lakshadweep Island. East Coast is mainly characterized by large fan-shaped deltas. World largest delta complex is the Sundarban. Huge mangroves are there. Bhitarkanika in Odisha, Pichavaram in Andhra. Also, we have a saline lakes like Chilka, Pulikat. We have a Gulf of Mannar connecting with Sri Lanka. West Coast is a very narrow coastal strip. We have a good estuaries like we have East Coast is characterized by a good number of deltas. West Coast is mainly the estuaries. We have Sabarmati, Mahi, Narmada, Dadar. These are important rivers from estuaries. We have a Gulf of Khambat. We have a Gulf of Kutch. Lots of industries are there in the West Coast. Limited corals, extensive mangroves are there also in the West Coast. West Coast, we have creeks, backwaters, sandy beaches. Andaman Nicobar are mainly the densely forest, meandering saline creeks, and the corals are there in the Andaman. Mainly the fringing reefs and the barrier reefs. Lakshadweep are mainly the atolls. And also above all, we have the 14 marine in the coastal protected areas covering a good hectares area in the marine protected areas. So this is what basically we have when Indian coast is concerned. Now, what are the major issues? Now, if you want to develop a coastal zone, as I was telling you that there are a lot of issues. So what are the major issues in the coastal zone which you need to address? Like population pressure. So this is most important. Like our India is the second largest populous country in the world. So huge pressure is there in the coastal zone. So this more number of people are living, exploitation will be more, because everybody has to survive. Everybody has to earn their livelihood from the coastal zone. So pressure is tremendous. Because of this, mangroves and coral reefs ecosystem is declined over the time, degraded over time. We are clearing mangroves for setting up industries, for setting up hotels, a lot of things. Mangroves are being cleared in the coastal zone. The areas where it has been seen from satellite data, there is a municipal sewage wastewater disposal is a issue. It can be seen from the satellite data. Industrial effluents, solid waste disposal, industrial effluents, lots of industry, particularly in the sea west coast from the Gujarat, lots of industry effluent from the textile industry from Ahmedabad, they're dumping in the Arabian Sea. Solid waste disposal, the agricultural waste from various parts of the Indian coast, they're coming and dumping in the coastal water. As I was telling you, the natural disaster, though we cannot control the natural disaster, definitely, particularly the tsunamis, the cyclone, but we can work together to minimize the effect of the natural disaster. That is very important, so that we can save the person's life. For this, we are working for the warning system. Like we have a cyclone warning system, we have a tsunami warning system. They are very effective. Yeah, of late, it has been seen lots of places. The warning system has saved huge spaces, human lives. There's the impact of the aquaculture in the coastal zone. Aquaculture, which give you a lot of money for an exchange, but at the same time, it has a lot of negative impact on the coastal environment, particularly when groundwater is concerned, wetland is concerned, the fertility of the land is concerned. Coastal erosion is one of the important area we need to think of, because lots of lands are being eaten up by the ocean because of the coastal erosion. So we need to think why the erosion is happening. What is the reason for this? There may be erosion because of the anthropogenic reason, or maybe some natural reason, like at the time of cyclone tsunami. Obviously, there will be a lot of erosion, but at the same time, like sea level rise, we have a role for the sea level rise. Also, the protecting one part of the coast with some like breakwater or for some dike, it will aggravate the erosion other part. Like setting up a harbor also, like Paradip port, where it has come, it has been shipped downstream of the Paradip. Lots of erosion has been happened. So because of the port, it has disturbed the longshore drift. So if you're disturbing the longshore drift, it is going to affect the other part of the coast. So some part will be getting eroded, some part will be getting degraded. All these things study has to be incorporated when you are talking about the environmental impact assessment in the coast. So impact of the port, as I was telling you, all the ports which are important for the national improvement of any country, but at the same time you have to see for setting up particular. That's why you tell the port site selection. Site selection is very important. You should see it in such a site from the dredging point of view, from the navigation and depth point of view, from the environmental impact point of view, from the erosion point of view, economical point of view. All these points should be considered before the setting up a particular site for construction of the ports. So there is a impact of the port on the coastal zone. Coastal mining, it aggravates the erosion. Lots of places sand mining is happening, heavy minerals mining is there in the coast. I was telling you, coastal construction, lots of new infrastructure is coming up in the coast in the form of industry, in the form of urban areas, hotels. So those kinds of construction are also having a lot of impact on the coastal zone. Ingress of seawater, that is also an issue in the various parts of the coast where the fresh water is being pushed back towards the land by the saline water. So we are deprived of particularly the people who are living in the coast, deprived of the potable water. So those tube wells and other areas where earlier we used to get the fresh water for drinking purpose or agriculture purpose. Those now areas of late, it has been seen that the water in the aquifer, they have been replaced towards the land, and they're replaced by the saline water. So if you now putting a dug well, you are getting a saline water, so which are not good for the drinking, neither for the agriculture purpose. So impact of the power plant, as I told you, power plants, the effluents are highly toxic in the form of when the temperature is very high. So they create a lot of environmental issues in the coastal water. Then obviously impact of tourism is important, because all the tourists are not environmental friendly. They used to put a lot of plastics, littering of the coastal area. They also destroy the corals. So these are the issues which also need to be considered. So what are the various activities for the coastal zone? Basically, we see first, if you want to manage a coastal zone, you need to collect data concerning any part of the coastal zone where you need to work. You have to collect all sorts of data. And as I told you, coastal zone is very, very dynamic. So it changes very fast. So you need to collect the data, up-to-date data. You have to rank the data reliability depending on their scale, what scale data you are collecting, what is the source of the data, what is the age of the data, what kind of data you are. So maintenance of this data. So keep it up to date. So like bathymetry, like if you're talking about the depth data, bathymetry also changes. So you have to need to use the latest bathymetry data. Like also like erosion and accretion map or the shoreline map of the coastal zone, which is changing also very fast. So you need to see the latest shoreline map of the coastal zone you should use. Like same way like coastal resources. Resources also somewhere mangrove is being degraded, somewhere new mangrove has come up, somewhere new wetland has been reclaimed. So those things are changing very fast. So you need to, even for the resources purpose, you need to collect the latest available data for the coastal zone. Now monitoring the inventory studies. Inventory studies means from the satellite data, it is very easy. You have to classify all the resources, accurate classification with lots of ground control point going to the field. Then finally you can quantify how much sand dunes are there, how much sandy beaches, what is the area of the sandy beaches, how much is the mangrove, how much is the corals, how much is the wetland. All those things you can find it out. They are called as inventory studies. You are telling how much they are. Okay. Now finally you are generating various kinds of thematic maps. Thematic maps, I am seeing the maps being generated from the satellite data. Spatially, they have a scale, they have a north arrow, they have a coordinates. Those maps are maybe of the coastal land use landform map, coastal geological map, suspended sediment map, all kinds of map which are talking about the various kinds of parameters pertaining to the coast. So they are the thematic maps you are generating. Also, the coastal zone management activities doesn't mean only generate thematic map or the inventory study. They are the part of the coastal zone management. But at the same time, if you support the management of the planning activities by providing the necessary and the sufficient information of the coastal zone, that is also very important. That means also you are supporting the coastal zone management activities. You are supporting the planning activities. Even if you support the policy writing concerning the coastal zone, you are a part of the coastal zone management expert. You are helping for the coastal zone management. It is not that you need to be a scientist for this. That's why I told there is a role for the sociologists, demographer, economists, all has a role for when coastal zone management is concerned. Obviously, there are certain issues which is very difficult to get from the satellite data, or there are some questions. People are scientists are not understanding why this part is getting eroded, why the pollution is happening over here, why suddenly erosion is aggravated. You need to do certain kind of research. So research to access the management and the planning problem in the specific area. There may be certain issues, certain problems in a particular coastal zone. People are not understanding why it is happening. Definitely, you need to do certain research and come out with a solution why it is happening. So these are the another important areas which is part of the coastal zone management activity. Now I will show you certain diagram to certain satellite data which will let you know that how the anthropogenic activities are degrading the coastal zone. So this is a mangrove degradation due to aquaculture in the Kakinada coast in India, where you can see all the black square shape area. They are the aquaculture field. And the red color is the Taringa mangrove, which is a part of the Kakinada coast, where you can see the agriculture activities which have come here. Here earlier it was all mangroves. Now mangroves have been cleared and the agriculture practices come. And you can see all the white color, the spot, they are the ancient agriculture, the aquaculture. So this field they have now not using, because at a particular area agriculture practice cannot go for infinite time. After a few years, then that field has to be just you will leave the field and you will go for the another field. And this the left out place which is of use for nothing, it will become a wasteland because the soil will lose its fertility. We cannot grow any agriculture over there, and also because of the aquaculture, as I told you, you use a lot of pesticides, the fertilizers, and that trickles downstairs, and they mix with the groundwater, and it decreases the quality of the groundwater as well. So overall, it has been seen, though it brings a lot of money, but overall, the aquaculture creates a lot of negative impact when coastal ecology is concerned. And above all, the mangrove comes under the CRZ1. You cannot cut the mangrove for any kind of this commercial activity. So it is banned by law of the land. But still, people are practicing the aquaculture, which can be picked up by the satellite data. This is beauty of the satellite data. Like our Supreme Court has banned the aquaculture. Now, if you rectify the image and put it in a GIS environment, you can find out that how much total area. This is the image of the 2003. You can find out, you can digitize all the aquaculture farms. You can find out what is the total area of the aquaculture. Now you can use the data of the satellite data of 2022. Again, you find out how much aquaculture is there right now. If the area has been decreased, it's very good. But if area has increased, you find out which is the area where it has been increased. Does it increase converting the wetland or cutting the mangroves? Then obviously those kind of map you can put it in the program and can tell here the laws have been flouted. So these are the areas where satellite data has a lot of role to play with. Here also, that is the area I was telling you. Here we were discussing all the mangroves. This is the Koringa mangrove, the red color. You can see here. This is the Kakinada Spit. Here the Kakinada town, and these are the all mangroves which are come up. Here you can see here. This is the mangrove has been cut by for the aquaculture purpose. So satellite data it has become very clear. This is a ship breaking yard. This image I have downloaded only from the Google image, where you can see directly in the Alang how the lots of ships are anchored over here for breaking. Okay, because the ships has a life in the ocean. After that, the ships has to be broken because they are not suitable when voyage is concerned. The very strict law is there by international community. So International Oceanographic Commission or other body dealing with the ocean, international ocean. So these ships have come in the Alang for breaking purpose, and for the breaking purpose they use a lot of oxyacetylene and other gases, and there are like big iron plates. They are coming up from the ships. So and because of these activities, all the water near the Alang, you can see along the coast, even you can see the color change in the color. So they are the highly toxic polluted water. And the water is not staying only in the Alang. This water through the littoral current, they are migrating far deep in, from the Alang. So it is getting the water, the polluted water is migrating and it is getting polluted the other part of the coastal Gujarat. So this is very dangerous. But people are getting a lot of money out of this ship breaking industry. Lots of people that are involved in the ship breaking industry, or so many laborers are coming from the states like West Bengal, Odisha, and other poor states. There are concerned about the child laborers and all other things. And also the pollution is one of the important factors, because unless until you use the particular protective gears and other things, it's a very health hazardous industry kind of thing. At the same time, it creates a lot of pollution in the coastal water. So this is the issue. Lots of NGOs are working towards this, and finally, we should see how best we can manage, because coastal ship breaking industry is a huge industry. It is not that one day you can stop it. But at the same time, I told you, we have to see what best we can do to protect our coastal zone. And whenever the science part of the remote sensing is concerned, particularly what is their penetration capability in the water, whenever the remote sensing energy is coming over the ocean, what is how much what is happening, whether the different bands, like we have a green, red, infrared, SWIR, TIR, whether these bands will be penetrating. If they are penetrated, how much they are penetrating. So this is very important, because penetration capability, if we have a good penetration capability, we know the depth, we know various kind of sub-bottom features will be able to pick up only from using this multispectral satellite data. So it has been seen that red light or red band attenuates rapidly in the water. That means it attenuates, it cannot go much deep in the water. Doesn't penetrate deeper than 5 meters. It doesn't have the capability to penetrate more than 5 meters. So if using red band, you cannot have any information more than 5 meters in the depth. Blue light penetrates up to 15 meters. In clear water, even up to 30 meters. So blue light is the maximum penetration capability. So it can go even up to 30 meters. Green light penetrates as far as 15 meters in the clear water around the coral reefs. Whenever the corals are there, the water is very clear, because in the turbid water, coral cannot survive. In the Andaman Nicobar, in the Lakshadweep, few areas in the Gulf of Kutch, you can see water is like crystal clear, like a mirror. In these places, the green light can go up to 15 meters. So green has a good capability, 15 meters. The blue has up to 30 meters. Near infrared penetrates up to maximum depth of 0.5 meter. IR is fully absorbed. So in IR does not have any penetration capability. So even not penetrating also is a good quality, because NIR or IR is fully absorbed by the water. So this type of band will help you to find out the land and water boundary. It is also very important to find out land water boundary at a particular place. So what is happening? Like in a coastal area, if I use only the NIR band, the water part, it will be all the black pixels. The pixel values will be very less, maybe not 0, but maybe 10, 15 like this. These are all black pixels. In the land it will be get reflected. So the pixel values will be 100, 200, depending on how the feature of the land. So the land and water boundary will be very clear. So if you want to get the land and water boundary, this is the best band. for getting the land run out of one tree. Particularly if you use the multi-temporal satellite data, soil line particularly you can pick up using this type of band, and you can find out how the soil line is behaving which time. If you get the soil line in the multi-temporal domain, then you will find out that this part of the soil line is getting eroded. Here the land is getting eroded. Here the land is getting deposited. See, getting deposited and erosion is what? This is basically how the soil line is behaving which time, how the soil line is changing. The part, if today the area which is having land, okay, now after 10 years, if this part is gone, if this is water, that means soil line area, you can demarcate the soil line in a different position. That means this area is now no more land. It has become water. So erosion has happened here. So changing soil line will tell you which part of the erosion, which part is deposit. And now there are lots of statistical softwares are available. You can find out which direction erosion is happening, which direction deposition is happening, quantitative analysis, how much it is happening. So there are lots of software like DISAS and other things where you can do a lot of study. You can even predict the future soil line also. So what will be the, if this type of behavior continues, what will in 2030, 2050, how the soil line is going to be here in this place. These are very important from the managerial point of view. If I can tell any decision makers, so this is the area, and this area 2030 soil line is going to be like this. It will be very easy for the planners to plan accordingly. Okay, so these are very important areas to find it out. So this is what now, what is the utilization of the remote sensing data? If you summarize, then we will be able to see that few things like various kinds of parameters, various kinds of resources like mangroves, coral reefs, salt pans, agriculture, wetland, other coastal inland resources, remote sensing compliances that we can map and monitor in a different scale, and it is operational status. Operational means absolutely there is no doubt. Depending upon the spatial resolution of the satellite data, I can map and monitor the various kinds of resources in a different scale. Okay, like fisheries, forecasting and monitoring, potential fishing zone is very important. Okay, so that forecasting and monitoring is possible using satellite data, which is semi-operational using, because no IIRS will give you the sea surface temperature, skin temperature mainly, and the IRS P4 will give you the chlorophyll concentration. Okay, but IRS P4 chlorophyll concentration, the algorithm is not, it's not a robust algorithm in the sense that same algorithm cannot apply to various kinds of coastal scenarios. It depends on the like case specific algorithm need to be developed. That's why it has been written semi-operational, because basically the coastal water is a case 2 water, and the optical property depends on the various kinds of heterogeneous objects, the phytoplankton, the yellow substances. So it makes the coastal water very complex. So that is why the case 2 algorithm is not very easy to develop. Compared to case 2, the case 1 water, the algorithm is rather simple, because here we know what are the parameters which control the optical property in the open ocean, but not the same in the coastal water. So also like coastal geomorphology, soil line changes, mapping, monitoring in different scale is possible. It is also operational using high resolution satellite. Sea surface temperature, wind, wave, water vapor. These are very important for fishery forecasting, monsoon study, ocean and atmospheric studies. So they are also operational with the IIRS Indian remote sensing satellite data, and also other lots of foreign satellites are there. They will help you out for this. Upwelling, eddies, gyres, they are very also important. Where from the ocean bottom, the cold water along with lots of productive, productive water, nutrient-rich water, but cold water, they are coming from the bottom and mixing in the top warm water. So these are the areas also they are very important for the fishery forecasting. So those are the areas where chances of getting fish are more. So we need to understand where there is upwelling, eddies, and the gyres. So they are important for the ocean dynamic point of view also. So they are operational. They are also operational. It is very. It has been proven that we can do it with the various kinds of Indian remote sensing sensor and the other sensor, and also the other foreign sensor. Coastal regulation zone, which is important to see what kind of prohibited and permissible activity there in the coast, and also the mapping of the CRZ, which has been given by the Ministry of Environment and Forest, and those mapping and the monitoring in a national scale in 1:50,000, and also few area 1:25,000 has been done. Okay, so this is operational. Suspended sediment concentration, also it is possible to get the quantitative analysis of the suspended sediment from the IIRS P4 sensor. The oil slick study, which is also one of the most important coastal pollution, which is important to monitor how they are migrating with time. So that is possible from also multispectral data as well as mainly the active sensor data, microwave data is being used to monitor the oil seep study, to understand the oil seep study. As we know, as we already told, that chlorophyll concentration, surface and the current and the near circulation pattern, they are also possible from the remote sensing. So this much of parameters you will be able to understand from the satellite remote sensing data. Now, as I told you, various kinds of hazards we can monitor. Mainly, we can classify them as a short term and the long term. Short term hazard means cyclone, hurricane, typhoon, tsunami, flash flooding. So these hazards are very dangerous, but they come and go. They don't stay much. Okay, time is less. Long term, the chronic disasters. They are also quite dangerous, but it's a very slow process. Land subsidence, sea level rise, coastal erosion like this. Cyclone basically, we call it is a atmospheric closed circulation rotating counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Along with cyclone, there is rise in the sea level accompanying the cyclone, which is called as the storm surge. Typhoon and the hurricanes are the tropical revolving storms. They are called cyclone when they occur in the Indian Ocean. So depending on the place, where other places in America and the Canada, we'll call them as a tornado or the typhoons. So it's basically, as I told, it's a low pressure system, deep pressures around which the air circulates in the anti-clockwise direction in the northern hemisphere and clockwise direction in the southern hemisphere. And the speed of the circulating air must exceed 33 meters per second near the Earth's surface. This is what the speed limit. Whenever there is a tropical cyclone, you see there are multiple disaster happens with a single tropical cyclone. So there will be strong wind, there will be local storm surge or the sea level rise, and they are associated with heavy rain. Strong wind, they cause damage to the structures, and also strong winds cause destruction of the crops. Damage to the structures is damage to the structures, and also the storm surge and the sea level rise. They are causing flooding. Flooding also causes damage to the structure. Flooding caused loss of life. Damage to structure also caused loss of life. Heavy rain associated with the cyclone, they also cause flooding. That means from a single cyclone, they are causing damage to structures, flooding, loss of life, destruction of the crop. Everything is being caused by a single disaster. So it is very difficult to understand basically where the cyclone will come, where the place will be the landfall. At the time of landfall, what is the speed of the wind, and all those things are very, very important to understand, particularly when human life is concerned, human infrastructure is concerned, agriculture is concerned. And nowadays, satellite data is one of the most important parameter which is going inside the IMD model, very high resolution model, highly mathematical model, which help you to predict the cyclone before it happens, before it landfall happens. These things are happening. So this is the eye of the super cyclone on the inside series satellite, how it is originating in the ocean and how it is migrating in the Odisha near Paradip. This is the super cyclone. It happened during 28th October to 30th October 1999, and surprisingly, as per the prediction, during those days, prediction was not very accurate. So the prediction was that cyclone will hit the Odisha coast, then it will migrate along the coast, it will come to West Bengal, and finally it will die up in the Bangladesh. But unfortunately, it didn't go anywhere. It remains and rotated within Odisha coastal only during the 29th October to 30th October. And that's why it got the tag as a super cyclone, which is the last the cyclone tag is the most dangerous disasterness of particular cyclone. And this is the INSAT series satellite, which shows the cyclone movement. Particularly, we can find out how the cyclone eye is movement is happening which time. Now we can do the track prediction. We can find out the track of the cyclone before it hits the coast. We can predict which direction the cyclone is going to come. We can pinpoint where the landfall will be. Now we can also talk about what will be the inundation towards the land. At the time of cyclone, what will be the wind speed? How much rainfall will happen? Everything can be predicted beforehand. No, that's why now you can see West Bengal, Odisha coast there, where cyclone is Andhra, where cyclone is frequency is very high. So those state government are always there on that toes. They're ready whenever this type of forecast is generated by IMD. Their regional centers, they take the requisite tapes, the district administrator, the collectors, chief minister, concerned chief minister of the state. Immediately the people, they have been asked to evacuate the places, all the kettles, everything they take care from the place, so that because you cannot take out the infrastructure houses along with you, but at least you can save the precious life of the human being and the other domestic animals. Also, the remote sensing can tell you the after cyclone, what are the health of the condition of the health, and the before cyclone and after cyclone. So this is a work done that super cyclone by the Odisha State Application Center, Remote Sensing Application Center. So this is the left hand side. What you are seeing, it is the NDVI. NDVI is the index of remote sensing index. Basically, we talk about the health of the vegetation. NDVI, the formula is IR minus R by IR plus R. Infrared minus red by infrared plus red. Values ranges from -1 to +1. -1 is mainly the water part, and more towards the +1, more healthier the vegetation. Okay. So this is the data. The left hand side, you can see the IRS 1C WIPS data on 11th October, and this is the post cyclone data. The right hand side, which is in the 14th November data. You can see the NDVI here. The ranges has been given. Multiplied by 10 basically, though the actual value is -1 to +1, only to see whole number, it has been given like this. So more the values towards the 5 or 6, the health is good. You can see the Bhitarkanika mangrove forest here, okay, along the coast. This is the mangrove forest where the values are, NDVI values is 6 or 5, all the coastal vegetation. So coastal health is quite good, but after the cyclone, you can see all the values over here, the changes 6 to 5, or here you can see all the green values, the 5 pixel, the values have been gone to 1. Lots of places waterlogged, the values has come to 1. So this will tell you how the health has been, health of the vegetation has been affected because of the cyclone. So you can able to show the map to the district collectors and say, sir, this is the area where the health has been highly affected because of the cyclone. Because remote sensing is giving you the clue, because you have an index called NDVI index, which will tell you the health. So lots of small vegetation, small mangroves, they will be under the water. Now, when the water will recede, they will come up. Then slowly you can see the NDVI values of the pixels, they are increasing. So continuously, if you monitor the data, you can see the few areas, the mangroves started coming up, because water will not remain there, water will recede, the mangroves will slowly come up. They will not die. But when the mangroves, which are uprooted, definitely they have died. So these are the all CRZ mapping. CRZ, from the high water line, 500 meters towards the coast. So this is the Panaji area. So the blue, the yellow line is the CRZ boundary. Here the black one is the high water line. The dotted is the low water line. So we made a buffer 500 meters from the line, and also now we can classify whether it is CRZ 1, 2, 3, and 4. Like CRZ 1 is the ecologically sensitive zone. All the sand dunes, the sandy beaches, the wetland, the mangroves, the corals, they come under CRZ 1. CRZ 2 mainly the coastal urban areas, the areas which have already developed very near to the coast. CRZ 3 is the coastal rural areas, villagers, hamlets, the fishermen's hamlet, and coastal CRZ 4 is mainly the Andaman Nicobar, Lakshadweep, other island which doesn't come under the CRZ 1, 2, and 3. So these are how the mapping has been done. Now I can classify the various CRZ 1, 2, 3, and 4, and I can superimpose the CRZ boundary. Then I can find it out what are the areas comes under the CRZ 1, 2, and 3, or 4. Like this, Space Application Center has Ahmedabad. The entire CRZ mapping of the entire Indian coast has been done in 1:50,000 scale, and few selected areas, important areas, 1:25,000 scale. Entire CRZ mapping has been done. So, particularly when GIS is concerned, coastal zone also there are a lot of role for the GIS, because the GIS talks with the spatial data, coastal zone data is also spatial. So why I use the GIS for the coastal zone? Because this is also important for the other branches of the subject also, because GIS is a platform where you can do integrate analysis of the larger database, and we can do a lot of quality control of the data. We can, in the GIS environment, we can do modeling and the simulation of the coastal processes. Lots of simulated, as I was telling you, the using models, we can find it out what are the areas which are getting eroded, and after erosion, how the area will look like. What are the future scenario of the sea level rise? What are the areas is going to be inundated because of the SLR? All those things, all the scenario we can generate. Then also we can do scenario testing. We can talk about the scenario testing for the management options, various kinds of management options we can give, and we can see the scenario, how this, if this option we are taking option 1, option 2, option 3, option 4, then how each scenario is going to happen. Those type of things are possible in the GIS. GIS supports the decision support, because definitely for taking a decision you need various kinds of options. So if these options I'm taking, then what is going to the scenario? Based on those options, based on the scenario generated, the decision makers will take that decision. Okay, particularly this is very important when there is a disaster. Where to put the reliefs? How to go to the place where actual disasters has happened? What will be the shortest route? All those questions will be answered by the GIS. So these are the very important activities what GIS can play with. This is what you can see the various kinds of layer, like ocean current, which will be vector data, ocean color images, which is mainly the raster image, bathymetry, which is a vector data, graded data. Also, it can be graded data as well as bathymetric contours. You can do as a vector data. Then various kinds of station measurement. So they are the point measurement data. We can see cliff maps, sedimentary phases, all the maps. You can bring them together in a GIS. You can superimpose one over the other, and you can make various kinds of decisions. So this is what the benefits of GIS. It is the ability to integrate data of the various types from different sources. It is an enhanced capacity for data exchange among various disciplines. It's the ability to process and analyze data more effectively and efficiently. You can do, we have discussed already, model, test, and compare various scenarios in a real world system. Updating of the data is possible in a GIS system, and also GIS has the ability to handle large volume of data. And also you can change the format, raster to vector, vector to raster. You can manage the various kinds of database. You can join the data, tabular data. You can join with the vector data, with the raster data. Those types of all kinds of analysis. You generate the digital elevation model, watershed boundary. Everything is possible now in GIS. But coastal GIS poses various kinds of challenges, which particularly other disciplines may not have those challenges. The working is, you have to always work with the three spatial dimension, X, Y, and Z, and is a highly temporal, working with a very high temporal data dynamic processor. But T is also very important. So it is not only, nowadays we don't talk about 3D GIS, it's a 4D GIS when coastal GIS is compared. Time is very important, because with time the scenario or the parameters are changing. The boundaries, the coastal boundaries is highly dynamic, and the boundaries are very fuzzy, and difficulties, we have a difficulty in defining objects. And also, unfortunately, we have a lack of coastal data model. So there is not a data model is available which can incorporate all sorts of data. People are working for a coastal data. Unless until you get a proper data model, your GIS cannot be successful. So that is not available nowadays. Till now, people are working to incorporate, because coastal data is coming in the various format, various forms. There are so much of forms are there, and to put all the data in a particular data model is a challenge to the coastal scientists. And also, coastal GIS is not a mature technology, as coastal data model itself is not a mature technology. So support from the commercial sector is slow but emerging. So from the commercial sector, unless until you get the support, as the land GIS application is highly commercial now, lots of GIS software are available, not for the coastal. The coastal managers and the scientists not yet a major lobbying group in the GIS. We use GIS, but those GIS, ArcGIS, IIRS, they are basically mainly for the land application. We are using from the coastal zone because there is no dedicated coastal GIS software. So we are using them for the time being and making use of that those data. Also, there is a issue with the coastal zone. There is an issue with the cost. Data cost is very high in the coastal zone, particularly, and there is a sensitive issue. Intercoastal zone, Indian coastal zone is classified. So you cannot design any map. You cannot use DEM, digitizing the Survey of India contours. So there is a security issue. Lots of coastal zone is highly, classified boundary with the international waters like Bangladesh, Sri Lanka, Pakistan. Also, you have to manage the time series data, so cost is becoming also increasing. And also, if data are available, whether the data is in a suitable form, also that need to be discussed. What form the data is coming, whether it is data from changing one format to other format is possible without compromising with the quality of data. All those things has to be discussed. Now, in the last few minutes, I think I will be able to show you some case studies of remote sensing GIS. Whatever I have told you so far, like you can see, this is a shoreline changes in the part of the Gujarat coast, where we have digitized the soil line from the satellite data of 2003, and the blue line, which the soil line has been digitized from the Survey of India contours of 1970. So I can superimpose in the backdrop. You can see the satellite data. The yellow line and the blue line is the soil line of 1970. Now you can see, compared to both the soil line, you can see the some part is totally under the water and some new land area has come up. So it's a very dynamic coast. You can find out how the soil line is been changing. This is a saltwater intrusion along the Gulf of Khambat, where you can see these are black lines. They are the salt pans, where the people are making salt during high water time. When the water is coming to the creeks, they get the water, gets evaporated due to scorching sun rays, and with little bit of processing, the salt. And Gujarat is the highest salt producing country in our state. But what has been seen of late that the water quality in the surrounding region where the salt pans are being mined, salt mining is salt farm activities are happening. The water is particularly the subsurface migration of the fresh water is going the reverse direction. That means they are going from the coastal zone and towards the land. So it has been seen, and we collected lots of water samples and analyzed their chlorinity content. And analyze them from the chlorinity content and make the contours and superimpose the contour in the area, and you can see the contours where the different colors of the contours denotes the different chlorinity content. The green color, which is having chlorinity content 250 mg per liter, and at the same time I should tell you that there is a standard of the potable water standard given by the World Health Organization or the European Union that you should not drink chlorinity content of your potable water more than 250 mg per liter. If you drink more than 250 mg per liter in the long run, that may create lots of problem in your body. So once I digitize all this, make the contours of all the chlorinity content from the local water, like from the talabs, from the tube well, and other sources, it has been seen. The violet color is 1000. Okay, the red is 750. The yellow is 500. Only green is 250. So this side is the ocean, this side is the land. So all the village, like you see the Alang, Sosia, the Gundi, the Goga, Kalatalab. So this is all the area they are covering under the chlorinity content is 1000 mg per liter. So all the villages who are drinking water in this region from the underground sources, they are getting water which is chlorinity content is very high. So the safe contour, that is 200 mg per liter, is going far away from the coast. This distance is around 25 kilometers from the coast. So the places which are situated more than 25 kilometers from the coast, those areas only we are getting good, healthy quality of potable water. Okay. So this type of study is possible because of this is the migration of the saline water, and there are lots of reasons because of the unscientific withdrawal of the groundwater in the coast for making salt. The sea level rise because of the global warming. So these are the all issues which force the saline water to go deep inside and force back the fresh water deep inside the land. So we tried to understand here what is the vulnerability point of view, which will tell you which part of the coast is more vulnerable when saltwater intrusion is concerned. For this, we took this Bhavnagar district, and they are the all, you can see they are the all taluks here, and these are the oil locations. So groundwater oil locations in the Bhavnagar district, these points are the oil location. We collected data pertaining to total depth, static water level, total dissolved solids, carbonate, bicarbonate, chloride, which has been collected from the Gujarat Water Resources Development Corporation in Gandhinagar for the year 1983 and 2003 in every 5-year interval for the pre-monsoon May data and the post-monsoon October data. Because the scenario will change. Pre-monsoon scenario definitely will not sustain after the post-monsoon. Because after the monsoon, there will be a lot of shower, lot of fresh water will go inside the system. So the scenario will change in October. So this type of study needs the seasonal study, and we use model to find out how the scenario is changing. Now you see the saltwater intrusion scenario in the Gulf of Khambat. So this is the 2003 pre-monsoon data, where you can see the vulnerability ranking. The red is the highly vulnerable for the saltwater intrusion. This side is the ocean. This side is the ocean. This side is the land here, and this side is the land here. You see the red is the highly vulnerable. So the near the coast, the entire region is highly vulnerable. Then yellow, which is moderately vulnerable. Then the blue one is the less vulnerable. Then the green one, which is non-vulnerable. This is the pre-monsoon. The post-monsoon same, because we had the data. This is the part of this is the model called Galdi's model, where the various subsurface geological parameters has been taken into consideration to understand the vulnerability of the intrusion. You can see here. Now the highly vulnerable post-monsoon only the restricted in this pocket. The other part, which was the highly vulnerable, become moderately vulnerable. You can see the less vulnerable area has been increased. Non-vulnerable area, which is not at all vulnerable for the saltwater intrusion, this region intrusion is not possible. So here, this area has also been increased. So this is where we can see how the vulnerability is changing with time, with pre-monsoon, post-monsoon, and in GIS, then we can find it out. How much is what is the total number of villages affected in the pre-monsoon, and what is the total number of villages affected in the post-monsoon? You can see all the black points. They are the affected villages. This is the pre-monsoon. Affected village means here the chlorinated content is more than 250 mg per liter. Here the post-monsoon, and it has been seen in the number of village, particularly in the post-monsoon, more than 250 mg per liter. It has been reduced. But the pre-monsoon time, the more villages are coming under the post-monsoon time. And then along with every village, we have the population data from the census department. And we see the population, and we can find out that how much population is affected with more than 250 mg per liter chlorinated content in their potable water in the pre-monsoon time, in the post-monsoon time. So this side is the pre-monsoon time. So you can see the pre-monsoon, more villages are affected. In the post-monsoon, less number of villages. Same way, these things have been done. So this is I will say in the last. This is the potential fishing zone study. What we did here, basically, we are trying to get the areas, the thermal font, which is basically mixing of the cold and the warm water, where from the bottom the cold water, nutrient-rich cold water is coming and mixing of the warm water. So that will create a thermal font, and that font can be picked up by the satellite data, particularly the IIRS data. So these are the font and some typical characteristics. So these are the font where there is a sudden variation in the temperature. Okay, so we are trying to look for this font for the chlorophyll, and you can see this is the SST map from the IIRS data, 23rd April 2001 in the Bay of Bengal coast. You can see the eddy or gas, circular shape. Okay. That means here from the bottom, the cold temperatures come. You can see there the temperature is 24, in between 22 to 26 degrees centigrade. But you can see the surrounding, the color, the temperature is little bit of more. But in this region, the circular shape, the temperature is less because the water has come from the bottom. That means it has it is or the upwelling zone. So we will look for the potential fishing zone or the fish catch in this region. But not only the SST. After that, when we have the chlorophyll sensor, we try to see what is the chlorophyll distribution map. If this area coincides with the high chlorophyll, that means it will be a potential fishing zone. But we have to see the IIRS P4 map on the 23rd April only. And you can see that 23rd April 2001, this is a phytoplankton retrieved from the IIRS P4 data, and we can got the phytoplankton map. Now you can see the phytoplankton basically in the coastal zone, phytoplankton is more. You can see the color, the color bar. It is in mg per cubic meter. The phytoplankton concentration is more. When you go air from the coast towards the upper ocean, chlorophyll concentration is decreasing. And you can see whenever putting one over the other in the GIS, you can see perfectly it matches the chlorophyll. High chlorophyll matches with the AD. That means because of the AD, the concentration of chlorophyll is high over here. So this region is high PFZ zone. Then there is a medium PFZ zone, low PFZ zone. This type of zone is generated. So this is the potential fishing zone map on 23rd April. This type of map is generated. So we have the certain kind of the study on the tsunami, because of the tsunami, the pre-tsunami and the post-tsunami. So this is the pre-tsunami image, the post-tsunami. So only a satellite data without doing anything, you can see how havoc the destruction because of the tsunami. From the satellite data, we will be able to find out. So this is the Marina Beach. In the pre-tsunami, this is 26 December 2004 tsunami came. So this is 12 January image. You can see here the circle, the yellow circle. This is the Marina Beach here, but the post-tsunami 27 December, IIRS list for multispectral data. You can see this is all Marina Beach is waterlogged. You can see new creek has been formed. There is a temple. The entire temple has been destroyed. So this type of data we can find out from the satellite data. And satellite remote sensing is very helpful to finding out the inundation due to tsunami. Also, how much water has gone deep inside the land, but also the water inundation, you can find it out. But because once you know the inundation, then you can find out, you can superimpose the village boundary map of that region, and I will be able to tell the local people, local district magistrate, these are the villages which have been marooned, and I know the population, and I will tell well, this much of population is in distress. So accordingly, you will try to send the relief, send the food packet through helicopters, because you need to know where to put the food packets through helicopter. Unless until you have the coordinated information, you will not able to know. Unless until you know the total number of population, unless until you know the what are the inundation area, you will not able to help them out. That's why sometimes it has been seen that where the relief is so much of required, there is no relief. Where the reliefs are getting rotten in the godowns, that much of relief is not required. So this planning is not there. That planning is very much required. That for this planning, use special techniques on satellite data and the GIS we are very much helpful. So this is how the map has been generated during those days in the tsunami. You can see the blue hatch line. So this is the tsunami inundated region. Okay, because inundation depends. Inundation cannot be the straight in the land. Inundation depends on a lot of local factor. Like it will depend on the earthquake parameter, nearshore bathymetry, beach profile, land topography. Okay, those things. These parametric variation, the inundation varied from one location to other location. And you can see the various taluk boundary, village boundary has been put. This type of map has been generated. This is from the Nagapattinam region and given to the Home Ministry, so that immediately remedial steps can be taken over. Thank you very much.